This is a review of the Conics sections, 7.2 Parabolas. Let's look at an equation for a parabola and break it down into some information that we can get from this form. The first thing we can tell from this form is that x is the variable that's squared. Notice that y is not squared. When x is the variable that's squared, we know the parabola either opens up or down. If the sign on this side in front of whatever number is here is positive, it opens up. If this sign is negative, it opens down. So let's make note, from this we can tell the parabola opens up. Because that 4 is positive, because it's an x squared. What else can we tell? Well, this is called the vertex form of a parabola. So the vertex, the standard form, let's write that. X minus h squared equals 4a, and we won't worry what a is. In this problem, a was 1, that's why it's just 4. Y minus k. This is the standard form for a parabola that opens up with vertex h, k. So the vertex here, x minus h must be 4. So our vertex is 4, y minus k. Y minus, well, what are we subtracting here? It would have to be negative 3. In other words, you're going to have to switch the signs because of the standard form having subtraction here. So this is the equation in vertex form of a parabola that opens up and has a vertex of 4, negative 3. So if I wanted this one to open down, and this is our standard, let's see, x minus 4 squared equals negative 4y plus 3. This negative right here now means that this is a parabola that opens down, but it has the same vertex, right? 4, negative 3. Now let's look at some parabolas that will open the other direction. What if we had y minus 4 squared equals 4ax minus h? X, let's call this one plus 3. X plus 3. I wanted to use actual numbers first. Okay, so the y is squared this time. Y being squared means it opens either to the left or to the right. This number here, no matter what a is, and let's just let a be 1, so we just have, let me rewrite this so it looks better, 4x plus 3. Okay. We know because y is squared, it opens left to right. Because this number, whatever it is positive. The number in front of these parentheses is positive. It opens to the right. Our standard form being y minus k squared equals 4ax minus h. Again, this one would open right and have a vertex of, h. K. Now be careful with this one because h is with the x coordinates with the x, the y coordinates with the y. So let's go back up here. So what's the vertex here? This one has a vertex of negative 3, 4. There's my h, x minus h, negative 3, k, y minus k, 4. How would we have one like this that opens to the left? Well, y minus 4 squared equals negative 4. X plus 3 would be a parabola that opens left because this is negative. It's a y squared with a negative over here. Opens left with a vertex of negative 3, positive 4. So we need to know those standard forms. If you can recognize when it's in vertex form, so these are all in vertex form, we have x minus h squared equals 4ay minus k. Opens up with a vertex, switch the signs, hk. X minus h squared equals negative 4ay minus k. Opens down. Same vertex though, I didn't change that, hk. Y minus k squared equals 4ax minus h, positive, opens right. Vertex would be hk. And y minus k squared equals negative 4ax minus h, opens left with that vertex hk. So all you need to be able to do, as deep as we're going in parabolas in this course, is recognize the direction of opening and the vertex when it's in this form. Okay, our next conic is an ellipse. That's 7.3. We're only going to be concerned with an ellipse that's centered at the origin. They can move all around the coordinate plane, but we're not going to be studying those. We're just looking at the ones centered at the origin. So if they're centered at the origin, we have two options. We can have an ellipse that is elongated along the x-axis. In other words, we say x is the major axis. Or, of course, we can have one like this, centered at the origin. So now y is the major axis. So what do we have to know about these? Well, we need to know that this distance from 0, 0 to this vertex, these are vertices on the major axis, is the distance a. So that means if that's 0, 0, then that's the point. X is a, y is 0. And this is the point. X is negative a, y is 0. And the standard form for this is x squared over a squared plus y squared over b squared equals 1, where a is a bigger number than b and they're both bigger than 0. So if you're given an ellipse in a certain form, a squared and b squared will just be numbers. You will know that the larger number is under the major axis because a is bigger than b, so a squared is going to be bigger than b squared. And for the y, if it's centered there, of course, then we'll have x squared over b squared plus y squared over a squared equals 1. The bigger number will be under y. And you know this distance here is a, so this point is 0, a, and this vertex is 0, negative a. So that's the other thing we know. The vertices here, plus or minus a, 0, and here, 0, plus or minus a. I don't think you can see all that. Now, what is b? Well, b is this other distance to the other vertex, the shorter distance. So if you're looking at a graph, you can see what b is. Blow it up, if you're given a graph, blow it up and look at it and see what that number is. Then you know that number squared must be under the minor axis, right? So the major axis has the larger number, this distance squared. The minor axis has the smaller number, this distance squared. Okay? So we'll look at an example of that. Say I had x squared over 9 plus y squared over 16 equals 0. Oh, equals 0. Equals 1. Sorry about that. That's the standard form. So what I know is y is the major axis. How do I know? The bigger numbers under the y. What do I also know? I know that a squared equals 16, so a must be equal to 4. So if I'm trying to match an equation to a graph, I'm looking for an ellipse that's elongated on the y-axis, because that's the major axis, and that the distance to the vertices is 4, because A is 16. Now, what if there's more than one to choose from in a multiple choice situation that have 4? Well, what's B? In this case, B squared is 9, so B is 3. So I'm going to look for the one that has this distance of 3 for my ellipse. Okay, that is the ellipse. And in the next video, we'll look at a hyperbola.